Welcome to queenon7.com. Please do share and subscribe my videos. We're going to look at the third carbonyl group, which is carboxylic acid. So whenever you see the functional group with the COOH bond, which you can write it as this as well, this type of functional group is actually an indication of presence of carboxylic group. To name them, it will always be written at the end of the carbon chain. So you will have a carboxylic group like that. You start the numbering from the carboxylic group 1, 2, 3. The parent name will be propane, and because you have the carboxylic group, you have to replace it with oic acid. So you replace E with oic acid. So propane oic acid or propanoic acid. Now, if I replace this and I put a side chain, and it will still be started from the numbering will be started from the carboxylate group. So 1, 2, so 2 chloro propanoic acid. You don't have to write down the numbering for the carboxylic group because there will always be at the start of the chain, so you don't need to worry about that. If you have more than one side chains, they will be named in alphabetical order, which you have done that in alkanes chapter when you actually did the naming the hydrocarbons. So now we're going to start with the acidity. Now the carboxylic groups, they are weak acid as compared to nitric acid, sulfuric acid and hydrochloric acid. If you look at it, they will actually dissociate just same like normal acids, but the dissociation will be very minimum. That's why they are very weak acid. Small acids, they are actually they dissociate, but they also make some sort of hydrogen bonding, so they are a little bit soluble as well. So the solubility will be the small carboxylic groups are more soluble as compared to the large carbon chain carboxylic group. Delocalization. Now this is an important point. If you have a normal, for example, ethanoic acid, and you have ethanoic acid like that, after dissociation, it actually try to stay in this condition. Now, when you look at it, the negative charge will be delocalized. So I am going to remove that, and I will actually leave all of this negative charges there. So this will be actually delocalized. So just let's put it the dotted lines there. Alkyl groups are actually known as the electron donating species. So that means the electron density will move towards the carboxylic group, and that will make it less stable. So it will be less stable. So this ion will be less stable because it has more electron density. So it will hold the proton more tightly, will not allow to dissociate very quickly. So it will make the carboxylate ion less stable because of this alkyl group. Hence, it will be a weak acid. Now, if I try to change this group where you have CH3 CH2Cl, and then you have C bond O, and you have delocalized negative charge on the both oxygen. Now, if you have this sort of molecule, though if there's no chlorine, yes, this will be less stable. But if you have chlorine there, chlorine is more electronegative, will pull the electron density more towards itself, and this will shift actually. The electron density from the carboxylic group will shift towards on the left hand side, will make it more stable. It will be more stable, and that way it will be a strong acid. Now we're going to look at the salt formation by the carboxylic group. I'm going to remove this, and I will look at the reaction between the carboxylic group. For example, if you have a ethanoic acid, you do remember when any acid reacts with an oxides or hydroxides or carbonates, they always make salt, and then they make hydrogen gas and water again, and with carbon dioxide with the carbonate. So if you look at this carboxylic group, it will react with the sodium oxide, for example. It will make a salt straight away, which will be sodium acetate ion, sodium acetate salt, and then it will produce hydrogen gas. If you use hydroxide instead of oxide, it will produce the same salt again, but this time it will produce water. And this is actually known as neutralization reaction. If you remember, alkali, when they react with any acid, they undergo to make a salt and water, and salt and water formation is actually called neutralization. The third one is the identification of the presence of the carboxylic group. And how are you going to do that? If you actually react with a carboxylic group with a carbonate, it will have some sort of power to liberate the carbon dioxide from the carbonate. So this will make the salt as it is. It will produce carbon dioxide and plus water. It's just same like as you have actually reacted the acid with the metal carbonates when we have done in the GCSE. Here you need to remember that when you actually have different sort of carbonyls, to distinguish between the carbonyls, the first test you actually do is the reaction with the carbonates, and that will decide whether this carboxylic group is actually present in there or not. Now the next part is the oxidation. Carboxylic acids, they never actually undergo the oxidation, but only except one, which is where you have methanoic acid. Methanoic acid does have a free hydrogen on the other side, which is normally not present in ethanoic acid and propanoic acid. Now this one can undergo further oxidation. If you do further oxidation under K2Cr2O7, and you can use the dilute sulfuric acid H2SO4, which will help you to complete oxidation. Once you do that, you will look at that this whole thing will be converted into the carbonic acid. So the carboxylic groups cannot go under further oxidation under reflux, which you have done in terms of primary alcohol, which when they have converted into the sulfuric acids, but they are converted into the aldehyde and then ketone for the full oxidation. Thank you very much.